So hey guys, we're back with next video that I promised that we were going to do, and this is multiplying fractions using calculations. Now this is a slightly different process than you're used to if you've been simplifying fractions, because the purpose of using cancellation is kind of the same. You'll get the same answer if you do the fraction first. If you multiply the numerators and multiply the denominators, and then simplify. This step is slightly different. What you're doing is, in a way, you're simplifying the fractions while they're like this, and then coming out with the answer at the end. And sometimes doing it this way, you won't need to simplify anything towards the end. Sometimes it doesn't work that well, but we'll get into explaining why you would want to do this instead of just doing it the ordinary way that we learned before. For example, the ordinary way for doing it would be, this particular sum would be 3 over 5, or if you remember how to do it, it's numerator times numerator and denominator times denominator. So it would be 3 times 10 over 5 times 7, and that equals 30 over 35, right? Which is the answer, but then if you want to simplify, you're going to have to take some further steps. Now I'm going to show you how we use cancellation, and after I've shown you, I'll explain why cancellation is actually better for a problem like this. So, what is cancellation? What is multiplying fractions by cancellation? Well, simply put, when you're using cancellation, what you need to do is look at the denominators and the numerators and see if you can see any common see if you can see any common factors between the numerators and the denominators. So what you would do is try to see if there's any common factors between 3 and 5, or you see if there's any common factors between 3 and 7, and then if you find any, you can do the process of dividing the numerator and either this numerator and this denominator by the common factor, or this numerator and this denominator by the common factor. It doesn't matter which one you do, as long as you choose either this one or this one to do. And then you would look at 10 and do the same thing. Now the thing here, I must mention this: if you find a common factor between these two and you cancel by dividing by the common factor, you can't, that's finished, you can't use that anymore. Then you would have to look for 10 and 5 and see if there's any common factor. So in other words, once you find a common factor between a pair, between one numerator and the denominator, and you divide by that common factor, you cancel it down, then all you've got left is the remaining numerator and denominator, and you have to see if you can find a common factor for those two. But let's actually get into doing this so you can understand how I would do it when I'm learning. So the first thing you need to do, given that you need to look at one of the numerators, I've started with 3, right? And what you're going to do, you're going to try to find out if there's any common factors between 3 and 5 or between 3 and 7. So you could write out a list like this: 3 is your numerator, and then put 5 and 7 and write down their factors. So factors of 3 are 1 and 3, factors of 5 are 1 and 5, and the factors of 7 are 1 and 7, because all of these are prime numbers. So immediately what you see is, apart from 1, there is no, 3 and 5 don't have any common factors. So if you were going to try to find the simplest, if you're going to try and divide them both by 1, it will still give you 3 over 5. If you know the common factor is 1 and you divide that by 1, it's still going to give you 3 over 5, so that's not going to work. Now, does 3 share any common factors with 7? Well, it only shares 1 again, so you can't do any simplifying. So neither of those are going to work. So we've tried to look and see if there are any common factors between 3 and 5 and between 3 and 7. That doesn't work. Remember, the purpose, what we're doing, we're looking at the first numerator and seeing if it has any common factors with either of the denominators. In this case, no, apart from 1, which isn't useful to us. So now let's go to the second numerator, 10, and ask ourselves again, are there any common factors between this and that? 10, this numerator and that denominator, or 10 and the other denominator? And we can do this because we haven't found a pair. If we have found a common factor between 3 and 7, then this would be, we could cancel that out and write what, yeah, we could cancel that out, but we haven't found anything, so we can still use 10 and 7 and 10 and 5. So now what we do, list the factors of 10, which are 1, 2, 5 and 10, list the factors of 5, 1 and 5, list the factors of 7, 1 and 7. Now first of all, if you look at 1 and 7, do they have any common factors? Well, nothing apart from 1, and so 10 over 7, if we tried to divide 10 by 1 and 7 by 1, it's still going to give us 10 over 7. So, do we have any common factors between 10 and 5? Well, look down the lists. Yes, we do. We've got 5. So what do you do now? Well, you found a numerator and a denominator which have a common factor. So there's our multiplication of the two fractions. You found out that these two have a common factor. Now what you can do, and if they had more than one common factor, you'd choose the highest common factor. Well, the highest common factor is 5. So what we do is you divide them both by 5. Now what does that give us? Well, if we divide 10 by 5, that gives us 2. And if we divide 5 by 5, that gives us 1. So you get rid of the 10 and the 5 and you replace them with the number you divided 10 by, which gave 2, and the number you divided 5 by, which gave 1. So now our fraction, if you look over here, becomes 3 over 1 times 2 over 7. So can you see what I've done here? Sorry, it looks a little bit messy, but we had our normal numerators and denominators, and we were looking to see if any numerator and any denominator had what do they call them? Common factors. So if there was a factor of 10 that 7 or 5 had, or if there's a factor of 3 that 5 or 7 had, when it looks like we found that 10 and 5 share a factor, which is the number 5. So what we did is we divided by the factor, which is 10 divided by 5, which gives us 2, and then 5 divided by 5, which gives us 1, and we replace the original numerator and denominator with the new number, which gives us this. Now we can work this out. This equals 3 times 2 over 1 times 7, which equals 6 over 7. Now, if you tried to simplify this any further, you would find you would get 6 over 7 anyway, because they have no common factors. 6 and 7 have no common factors except 1. So essentially what you've done is you simplified all of this by cancelling down, and that has given you an answer, which is the actual simplified answer. So instead of doing 3 times 10 over 5 times 7 and then simplifying, because you're using cancellation here, it already does it for you. Now, why is it important to do this? Well, we're going to talk about this in a second. I'll show you why this is important. Let's say we had our calculation to do. 3 over 5 times 10 over 7. We know you have to work this out, you have to do numerator by numerator, which is 3 times 10, over denominator by denominator, which is 5 times 7. That equals 30 over 35. Now when you need to simplify that, because these numbers are so big, you would have to write a really long list of factors to find which one is the highest. So you'd have to do 1, 2, 3, 5. This is the factors of 30. 6, 10, and 30. The list isn't too long actually. For 35 you would do 1, I think it's 5, 7. That's one that's a bit harder actually. 3 doesn't work. 4, 5, 7. Yep. And it looks like it's probably 35. Anyway, the issue with this is you have to write quite a few more numbers. You have to write a long list of numbers. What if your final fraction turned out to be, I don't know, 185 over 622? Well, can you see how difficult that's going to be? You're going to have to write lots and lots of numbers to find all the factors of 622, and lots of numbers to find all the factors of 185. But if you do it this way, if you can cancel things down, we saw that this gave you a much simpler answer, which is 6 over 7. And then all you need to do is find the factors of 6 and 7, which is very, very simple. So the reason why we cancel down is because it makes it easier. It makes this fraction much easier to handle, because if you don't cancel down, if I gave you something like well, the answer to that is the number there. This number is 220 times 238. It's so gigantic, and so is this number. And then you would have to write an extremely long list of factors down just to be able to find the highest common factor. But what you could do is cancel these down to much smaller numbers, and then in the end you'll end up with a much smaller number, which will make it easier for you to find common factors. I know this video probably seemed a little bit complicated, but what I'm going to do is make another video and we'll do a few examples to show you how this actually works, because it seems quite complicated, but I'm sure you've got all the skills. You know how to find highest common factors, you know how to divide by highest common factors in order to make a fraction simplified. We're just doing things in a slightly different order, and it really helps, because once you've done that you get a much smaller fraction that you can handle. But anyway, in the next video I'll give several examples that we can look at, and so that you can get an idea how you can do this and you can practice along with me. So until the next video.